Hey everyone, welcome back. And today we'll be doing another lead code problem 146 LRU cache. This is the medium one. Design a data structures that follow the constraint of a least recently used LRU cache. Implement the LRU cache class. LRU cache constructor we are going to have, which will have the capacity. It will be a positive integer int get int key. It will return an integer. Return the value of key if the key exists, otherwise return -1. Void put, we are going to have a put method which will have a key and a value. Update the value of a key if the key exists, otherwise add the value to, key value pair to the cache. If the number of key we are going to add is or have in our map exceeds the capacity, then we are going to remove the least recently used key, and that's it. So let's see if we have a input like LRU cache, which will be the capacity 2, and we are going to put 1 1, we are going to put 2 2, and returns are just null, and we will get 1 because obviously 1 is present. Then when we are going to put 3 3, like you can see here, we are going to remove 2 because 2 was the least recently used one, because we didn't did anything with 2 was just added, and 1 was the most recently used because we get it 1 in the previous step. So get 2, because 2 is not present, we can just return -1. As you can see, -1 is here, and then we will put 4 4. Now when we put 4 4, we are going to evict 1 the key, and the value is 1 because 1 is the least recently used, and that's it. And after that we can just say like LRU uh, key was evicted because 1 is the least recently used, and if we get 1, we are going to return -1 because 1 is not present in our map. And dot get, if we can use again, we are going to have 3, and when we are going to get 4, we are going to get 4 because 3 and 4 basically are present in our map. So that's it. What we'll be doing here is using a doubly linked list, which the node itself is going to have 4 compartments: a key, value, and a previous node and the next node. Now that we are also going to use a hash map in which the map itself having a key value pair. The key will be the key. Obviously, we are going to have a key, like they will say pass the value of 1 and something like that, and get the value of 1, and the value is going to be the node address of the node in which we are going to have these 4 compartment: value, key, and previous node, and the next one. So let's say class uh, class node. We are going to have a node class in which we are going to have a constructor. So let's say def init constructor self dot key will be the int, and value will be also int, and return type is going to be none. Okay, so self dot key and self dot val, and let's just put it here, will be key and value. Okay, so self dot previous is going to be equal to self dot next, which will be none. Okay, so now we are going to implement the class constructor, LRU cache class constructor itself. Okay, so self dot capacity is going to be equal to the capacity we have. Okay, so another cache map, which will be just a map, and a left node and a right node. So I will tell you what we are going to do with our left node and right node. The left node is going to be the node that is on the next of it. So left dot next is always going to be the node which is the least recently used, and the previous of the right. So let's just correct the spelling. Right is going to be the most recently used. So that's it, and these two will be connected from each other. Every node we are going to add or remove will be in between left or right. So left dot next and self dot right dot previous will be equal to self dot right and self dot left, and that's it. Yes, this looks good. Now we are going to have another method, remove a helper function, you can say, remove, which will be having a node. So we are going to remove a node, so we will just say node. Return type of it is going to be none, not returning anything. And again we are going to have another method, insert, which will have self. Obviously we are going to insert a node, so it will be like node. Okay, so this is done. And return type of it is also going to be none, none. Okay, so this is done. Let's just say remove first. So remove, the node is being passed, so the previous and the next, we are going to have a next one will have, so the previous is obviously going to have the previous of the node, and the next is going to have the next of the node. So we can just say node dot next. Okay, so previous dot next should be equal to next, and next dot previous shall have previous. So this is, yes, I think we deleted the node because the previous of that node is now pointing to the next of it, and the previous of the next is pointing to the previous node, which was the previous of the node which we are going to remove. So now we'll have previous again and a next for insertion. So when we are going to insert, we are going to add it at right dot previous, because this is going to be the most recently used. So self dot right dot previous is going to be the previous, and self dot right itself is going to be the right, uh, next basically. So now previous dot next is equal to next dot previous, which will be the node. So we connected our next node, our right and its previous, with this node. Now we are going to connect this node with these two nodes. So node dot previous, let's just say node dot next, and node dot previous. Okay, so node dot next is going to be pointed at right, so it will be right, which will be the next, and the previous is going to be pointed at previous. So I think this is good. So if the key is present in our cache, then we are going to just say like remove it, removing it and adding it to the right dot previous, because we know that right dot previous is going to be the most recently used, and then whenever we are going to evict, then obviously we are going to have left dot next, which will be the least recently used. So that's it. So self dot cache the key. Okay, so self dot inserting it at the end, so insert self dot cache the key. So this will just pass the nodes, because the value is in the form of a node and the key is going to be the key obviously. So then just return self dot cache key dot val, because obviously we are going to have it in the form of, now if we didn't do val, we are going to have a reference, and if we do dot val, then obviously we are going to have the data in integer form, and if we didn't find, we are going to return -1. And now input, if we have key, if key is present in our cache, then obviously we are going to remove it because we are going to update it. So self dot remove, passing it self dot cache the key. Okay, so now only making another node. So cache key is equal to node, passing it key and the value. Okay, so this constructor is called basically, and it will do the other stuff for us. And now we have to insert. So cache insert will take this value, so cache key as a node. So this node is going to be inserted in our linked list at the very right dot previous, at the right dot previous. And if the length of self dot cache exceeds the capacity, because obviously we are going to check the capacity. If it exceeds, then we know that we are going to remove the least recently used. Where we have a least recently used node, it is going to be at left dot next. So let's take LRU least recently used, and self dot left dot next will have the least recently used. We will call self dot remove remove will just remove this LRU, and after that we are going to delete this uh, from the hash map. So key dot LRU key, LRU dot key. So cache LRU dot key will just remove the values from the hash map, and that's it. Let's see if this works or not. The key in self, if key in self dot, okay. So there was a mistake. There is not going to be a key, so cache only. That's it. Node object has no attribute next. Obviously it is going to be the next. Let's see if there are any other errors. So this is a very long code, that's why there are many errors in it. So it works, and that's it.